Hello, good morning everyone. Let's start the session today. In the today's session, we are going to focus upon ER diagrams. In the last week, we have covered few basic concepts related to ER model. So we have covered the basic concepts like entity, entity set, attribute, relationship, relationship set. We have also covered the concept that is degree of relationship. We know what is binary relationship and how we can have the relationships with degree more than 2. Further, we have touched upon the concept of participation. We have talked about total participation and partial participation of the entity sets in relationship. Also, we have gone through the constraints and we have seen the mapping cardinality and the participation constraints. Also, we had a discussion about various keys for entity sets as well as the relationship sets. And we mentioned that we are having super keys, we are having the candidate keys, and we are having the primary keys. So in the last week, we have covered the discussion related to all those concepts with respect to ER model. So today we are going to start discussing ER diagrams, how to draw ER diagrams. So if we want to model our database system conceptually, then one of the data models that we have is the ER model. And typically ER model helps us to represent our database with a graphical representation. So it is possible now for us to represent a database by making use of certain notations diagrammatically. So we are having here the list of notations, those are being used, few of the notations. So we are having the notation that is rectangle. So we are going to make use of rectangles to represent entity sets. The diamonds are being used to represent the relationship sets. The lines are used to link the attributes to entity sets and also to link the entity sets to relationship sets. We are having the ellipses to represent the attributes. There are variety of ellipses, those we may have. So we use double ellipse to represent the multi-valued attribute and a dashed ellipse to represent derived attributes. We have seen what kinds of attributes we may have in our previous discussion. So if we want to represent a multi-valued attribute, we need to make use of double ellipse. Or if we want to make represent derived attribute, we need to make use of dashed ellipse. We are going to see all those concepts and notations by simple examples. Then to denote a primary key attribute, we need to make use of underline. Then double lines indicate the total participation of an entity in a relationship set. So whenever we are linking any entity set with a relationship set, if we make use of a double line, then it indicates total participation. Double rectangle represent weak entity sets. We are going to focus upon these concepts. But whatever concepts we have learned so far, we are going to draw ER diagrams now by making use of some real world examples. So let us see one example here, how to represent entity sets and attributes. So as we mentioned earlier in our running example of university database. Fine. So we have identified earlier that instructor is our entity set. And for instructor, we are having three attributes identified: ID of the instructor, name of the instructor, and salary of the instructor. So while drawing the ER diagram, we are making use of the notations now. So what are those notations? Entity set is represented using a rectangle. So this is my instructor is my entity set. So we are making use of the rectangle to denote the entity set. And these attributes are depicted by making use of the ellipse, right? So ID is the attribute, name is the attribute, and also salary is the attribute. So rectangle denotes entity set. We are having one more notation to denote entity set. Though we are making use of the rectangle along with the ellipses to represent the attributes, you may find another notation also in some literature, and this is also the valid notation for entity set. So how entity set can also be represented? See here, I am having one rectangle over here, wherein this rectangle is partitioned, okay, into two parts. In the upper part, we have mentioned name of the entity set, and below we have listed the attributes belonging to that entity set. So both the notations are valid notations, okay, but we are making use of this notation, rectangle along with the ellipses denoting the attributes. But this also is the valid notation for entity set, okay. Now as I mentioned, these ellipses are denoting the attributes, okay. And if I have the underline for the attribute, then this denotes the primary key. We know the concept of primary key. So what we mean by primary key? Anybody who can answer what we mean by primary key? Primary key of the entity set? Yes.
Oh, ma'am. Hello.
Yes.
Attributes of primary key never be changed.
Okay, so what is primary key? How to define the primary key? It is an attribute that uniquely identifies the entity. Correct? How to define a primary key? It is one attribute or set of attributes. Those uniquely identify the entity. Right? So here for this instructor entity set, I am having the attribute ID, right? And by making use of this ID, it is possible for me to uniquely identify every instructor. And that is why we are saying that ID is the primary key. And in ER diagram, if we would like to represent a primary key, we are having this notation underline for that attribute, which is the primary key. It may happen that more than one attributes work as the primary key, right? So combination of attributes is also possible. For this example, instructor entity set, we are having a single attribute that is working as the primary key. So ID is the primary key with underline, right? So these are the notations to be used to draw the ER diagram. Am I clear? Yes?
Yes, ma'am.
Fine. So let's proceed now with one more example wherein we are representing the composite attributes, the multi-valued attributes, and the derived attributes. Okay. So see here, which is my entity set here in this diagram, which is my entity set.
Student.
Student. Correct. So student is my entity set, and for student entity set we are having so many attributes. So please see here how we have represented those attributes. Now name is one of the attributes for student, but name is the composite attribute having described with three subparts: first name, middle initial and last name. So to denote the composite attribute, we are making use of this notation. The attribute is name, right? And we are having three subparts of this name. So those subparts are being linked to this composite attribute name. Right? So this is how the composite attribute is being denoted in ER diagram. Okay? Now, we are having here phone number, one of the attributes of student. So if we look at this phone number is represented as double ellipse. So what we mean by this double ellipse? Phone number is multi-valued attribute. What we mean by multi-valued attribute? This attribute can store multiple values. So we are saying that it is multi-valued attribute. So if in ER diagram, if we want to denote a particular attribute as the multi-valued attribute, we are going to make use of double ellipse. Okay. Now ID is a primary key for the student, so it is underlined. Right? We are having address. Once again, address is denoted as composite attribute. So address is having four parts: street, city, state and zip code or postal code. Once again, this street is represented as composite attribute. So street is divided into three parts: street number, street name and apartment number. Right? Now, we are having here one more attribute, date of birth. Okay, so this date of birth is actually storing the date. Okay, now if I want to store age of the student, then it is possible to denote this as the attribute. But as we have seen the definition of derived attribute, what is derived attribute? That can be derived from some other attribute, right? So age can be derived from the date of birth, and that is why age is my derived attribute. And if I want to show the derived attribute, then I'll be making use of the dashed line, dashed ellipse, right? So these are the notations for various kinds of attributes. Please look at it. How to represent the composite attribute, how to represent the multi-valued attribute, and how to represent the derived attribute. Right? And how to represent the primary key. Am I clear? Yes?
Yes, ma'am.
May I proceed?
Yes.
Fine. So let's go to now the notation for relationship set. So as we have seen earlier in our running example, we have identified one relationship set, advisor, between instructor and student. Right? So how to denote the relationship set in ER diagram? By making use of a diamond. Okay, so I am having instructor entity set with three attributes. Here I am having student entity set once again with three attributes. Correct? And in between these two entity sets, I am having this relationship, advisor. So instructors are working with students as advisors. Right? And notation we are observing here, some numbers are associated with this relationship. What does this mean? We are going to focus upon it later. Just remember, these are denoting the mapping cardinality for this relationship advisor. Okay. Now, the relationship can also be depicted, or the alternative notation for this entire thing, entity set, relationship, and the other entity set. So the alternative notation for this kind of representation is like instructor denoted with another notation, like student, that is the entity set, denoted with other notation, and advisor is the relationship set in between instructor and student, and that is being denoted with the same notation, that is the diamond. Okay, so relationship set between the entity sets is denoted with the help of the notation, that is a diamond. Okay, so advisor is a relationship set between instructor and student. Okay, so I hope the concept is clear. Let us proceed now to the next concept. As we have seen earlier, our relationship sets can have the attributes, additional attributes, own attributes. Let me give you the example. So here we are having the advisor as the relationship between instructor and student. So whenever we are drawing such kind of a relationship, by default for this relationship set we are having two attributes. And what are those two attributes? The primary keys of the participating entity sets. I'll repeat. Whenever we are depicting any relationship set in ER model, by default this relationship set is having the attributes. Those are actually the primary keys of the participating entity sets. Meaning, for this advisor relationship, which two entity sets are participating? Instructor and student. So by default, this advisor is having two attributes. And what are those two attributes? Primary key of the instructor and primary key of the student. Right? But whatever are those default attributes, those we are not showing in ER model. Please understand. While drawing the ER model or ER diagram, we are not depicting the default attributes for the relationship. And what are those default attributes? Those are actually the primary keys of the participating entity sets. Those are not being shown here, right? Because by implicitly we say that these are the attributes of the relationship set. But if the relationship set requires some additional information to store, then we may have the attributes. Those can be linked with the relationship set. Say here we are having this date as the attribute for the relationship set. So it is possible that the relationship set is having its own attributes. And here we are having date as the attribute for the advisor. So why we are using this date? We have seen this earlier also with the same example. Why we require this date here to store along with this relationship? Because we want to maintain the information that when the instructor, or what is the start date, when the instructor has started advising the respective student, that information also we would like to store. And to store that information, we are making use of this attribute, associated with the relationship set. So the attributes those are associated with the relationship set are known as the descriptive attributes, right? So here date is the descriptive attribute. So please once again have a note that this relationship set advisor is having by default two attributes, and these two attributes are actually the primary keys of the participating entity sets. So for this advisor, I am having IID, maybe that is the attribute from this instructor, that is the primary key of the instructor. Similarly, I am having SID, that is the primary key of the student entity set. So by default these two are there. We are not denoting those attributes along with the relationship set. But if any additional attribute is required to store certain information for that relationship set, then we may make use of the descriptive attribute for the relationship set. Right? Now, in the other kind of notation, how this descriptive attribute is being shown here. Just look at this. This is the entity set, this is the entity set, this is the relationship set, and if I am having the descriptive attribute for the relationship, then it is denoted here with this dashed link. So this dashed link actually denotes that this is the attribute for the relationship set, and that is called as the descriptive attribute. Okay, so this kind of notation is also valid. We are making use of this notation. With respect to a relationship set, we are having denoted here date as the descriptive attribute. So this is attribute denoted by making use of ellipse, and that is linked to the relationship set advisor, correct?
Yes.
Fine. So let us proceed now with the next concept, and that is roles. So what are roles? Now, so far, whatever relationships those we have talked about, okay, those relationships are having such kind of the representation. We had entity set A, we had entity set B, and in between these two entity set we had the relationship set, right? And that is denoted by making use of this diamond. So far we said that in between two entity sets we are having a relationship, okay, or two or more, actually two or more entity sets may participate in the relationship set R. Now, it is not mandatory that the entity sets those are participating in the relationship set are distinct. It is not mandatory. What I mean by that, it is possible that one entity set participates in the relationship set twice. I'll repeat. It is possible that one entity set participates in the relationship set twice. What I mean by that, just I'll be depicting here with the help of a diagram. I'm having relationship set R. Okay, and what I said that it is possible that the same entity set, it's participating in the relationship set twice, more than once. So this is my entity set A, right? And what I'm saying is, instead of having two distinct entity sets, I'm having the same entity set, but that is participating in this relationship twice. It is possible. And if this is the case, then we say that this entity set is participating in this relationship set with different roles, and these roles are depicted by making use of the labels associated with these links. Let us see one example to make this idea more clear. Okay, so as I mentioned, entity sets of a relationship need not be distinct. So if this is the case, then A and B are distinct entity sets. Those are participating in the relationship set. But not necessarily always the entity sets participating in the relationship set are distinct. It may happen that the same entity set participates in the relationship set more than once. So it is possible. Now, let us assume one example. So what that example is, in our university database, let us assume that we are having course as the entity set, course. Okay, now you might have seen your syllabus or the curriculum. So many times you must have observed that for a particular course, another course is being mentioned as the prerequisite for that course. You might have observed this. Say for example, right now we are learning database engineering. Okay, but if you look at the syllabus for database engineering, it has been mentioned that for database engineering, the prerequisite is another course, and that is data structures. Or if you are learning data structures, it has been mentioned in the syllabus that to learn data structure, the prerequisite is the computer programming. Right? So, for many of the courses, there are certain prerequisites. What we mean by that prerequisite? Before enrolling for this particular course, you should complete this earlier course, that is the prerequisite. Okay? So, if we want to depict such kind of a situation using the ER diagram, then what we can see, or how we can show this. See, for example, whatever we are mentioning as the prerequisite, it is also the course, right? And this is the course which is the prerequisite for some other course. So this prerequisite relationship is between course and course. Course is the entity set. So course entity set is participating twice in this relationship set prerequisite, right? So towards one side of this relationship, we are saying that this is course ID, and towards other side of this relationship, we are labeling this link as the prerequisite ID. What does this mean? This means that these labels are indicating the roles. These are called as the roles. So what we mean by that? This is interpreted like this. Say for example, if this is my example, then I may say that the course ID for database engineering, for example, is having the prerequisite, that is the data structures. So the same entity set course is participating twice in this relationship set prerequisite. Am I clear? And the role is nothing but the label that is provided here. So how this course is participating in this relationship? once it is participating as the course, and at the other time it is participating as the prerequisite for that course, right? In fact, these labels are optional, but we are providing these labels for the roles because we would like to clarify the semantics of the relationship, right? So these labels actually help us to clarify the semantics, clarify the meaning. So this course, once it is participating in the prerequisite relationship as the actual course that is being opted by the student, and this another course or the another instance of the course is meant for representing the prerequisite course, right, for the course that is opted by the student. So this is how we can depict the roles by making use of ER diagram, right? I hope the concept is clear. If you have any doubt, please let me know. Very important concept. Many times we need to depict such kinds of relationships by using roles. Yes. Any doubt so far? Have you understood the concept of role? Yes. Have you understood the concept of role?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So, may I ask roll number 302, Ajinkya? Roll number 302. Are you there,
Yes, madam.
Ajinkya? Okay. So,
Yes, madam.
have you understood the concept?
Yes, madam.
So, will you please repeat what you have understood?
Roles means one entity participates in relationship twice. Means we can say that two entities, course ID and its prerequisite ID, are participating.
Okay. Fine. So, the roles are actually indicated in ER diagrams by labeling the lines. Those connect to the relationship, right? So by making use of these labels, actually we are trying to clarify the semantics of the relationship. So in this typical example, we may say that for one particular course, there is a prerequisite course. So obviously for this relationship, we need to have one entity set course that is participating twice, once as the course itself and once as the prerequisite course of that particular course. So the relationship set indicates which course is the prerequisite for which course. That is what we would like to depict with this relationship prerequisite. So what we are storing in this prerequisite relationship? The information related to the course along with its prerequisite courses, right? That's all. So the essence is, it is not necessary that always the entity sets, those participate in the relationship set, are distinct. Not necessarily. It is possible that one entity set participates in the relationship set more than once, right? So let's proceed now to the next concept, and this is related to denoting the cardinality constraints in the ER diagram, right? So to connect the relationship set with the entity set, we are making use of the links or the lines, right? So if I am having the directed line with the arrow, directed line means the arrow, then it signifies 1. And if I am having undirected line then it signifies many. So we have already talked about the cardinality constraints, the mapping cardinalities. So we are having four kinds of relationships: one to one, one to many, many to one, and many to many. So if we would like to denote one, then it is a directed line. If we want to denote many, then it is undirected line. So how to denote that? Let us look at this particular example. So whatever we are seeing here in this slide, this is a one-to-one relationship, one-to-one. So what we mean by this one-to-one relationship? With the assumption that a student is associated with at most one instructor via this relationship set advisor, and an instructor is also associated with at most one student via the relationship set advisor. So I'll repeat, a student is associated with at most one instructor, and if the instructor is associated with at most one student, then this relationship set advisor is one-to-one relationship. And to denote one-to-one relationship in ER diagram, we are making use of these arrows. So towards one side, we are having the arrows. Here it is one-to-one, so both sides 1. So we are having these two arrows. These are the directed lines from the relationship to the entity set. Right? So this is how we can denote one-to-one relationship. Okay? In the other way or the other notation to denote one-to-one relationship is like this. Along with this relationship, we may depict here the number 1, 1. So this also indicates that this advisor relationship is one-to-one. We may make use of any of these notations to denote one-to-one relationship. Okay? Either we may provide here the number 1, 1, so that this will indicate that advisor relationship is one-to-one. Okay? Or we may indicate like this with the directed lines. Okay? So what this one-to-one relationship advisor means? It means that a student is associated with at most one instructor, and one instructor is associated with at most one student. So that is one-to-one relationship. And this is how it is denoted using the ER diagram. Any doubt? Yes? Any doubt? Have you understood the concept?
Yes, ma'am.
Yes, ma'am.
Yes, sir.
Yes, ma'am.
Okay,
Yes, ma'am.
fine. So similarly now we are having remaining kinds of relationships: one to many, many to one, and many to many. So let us see what are the notations. So let us look at now one to many relationship. So whatever you are observing here is one to many relationship. What we mean by one to many relationship? Here one to many relationship is from instructor to student. So what does this mean? This means that a student is associated with at most one instructor via this relationship set advisor, and an instructor is associated with several students including 0. I'll repeat. One student is associated with at most one instructor, but an instructor is associated with several number of students. So this relationship set is one to many. One towards instruction and many towards student. So we may put 1 here towards instructor and N here. N stands for many. N here towards student. So that is one way of notation. In other way of notation, what we can do? We can put the directed arrow here towards instructor, right? And we are having undirected line towards student. So this is also indicating one-to-many relationship. Have you understood?
Yes, ma'am.
May
Yes,
I
ma'am.
proceed? May I proceed?
Yes.
Okay.
Yes, ma'am.
So let's see now many to one relationship. So in many to one relationship, exactly opposite, many to one. So many to one, many towards instructor, one towards student. Many towards instructor, one towards student. So how to interpret this relationship now? If it is many to one, a student is associated with several instructors, including 0. And an instructor is associated with at most one student via this relationship set advisor. Okay, so towards instructor it is n, towards student it is 1. Or with the help of alternative notation, how we can depict this relationship or this cardinality? Towards instructor it is undirected line, towards student it is directed line. Directed line indicates 1, undirected line indicates many, right? So many to one relationship can be interpreted like this. Once again, in this particular scenario, how to interpret this relationship set advisor? A student is associated with several number of instructors, but an instructor is associated with at most one student. That's all. So many to one. Am I clear?
Yes, ma'am.
Yes, ma'am.
Okay. And the last cardinality constraint, many to many. So how to depict this many to many? Obviously, you can think of this is many to many. Instructor, towards instructor it is many, towards student also it is many, right? Towards instructor it is undirected line, towards student also it is undirected line, or both the numbers denoted here are n, many to many. So interpretation for this relationship is like an instructor is associated with several number of students and a student is associated with several number of instructors, possibly 0, via this relationship set advisor. Got it? Yes. Any doubts so far? Any doubts so far? May I ask roll number 365, Muskan Mullah. Are you there, Muskan? Roll number 365. Muskan.
Yes, ma'am.
Yes. Have you understood the concept?
Yes.
Now, if I give you one example, like see here, I'm drawing. This is my entity set A, right? This is my entity set B. Okay, and I'm having this relationship set in between these two. This is R, right? If I'm having arrow towards A, how will you interpret this? Yes,
Ma'am, I can't get it.
So you have not understood. You said it, you have understood.
Sorry, ma'am.
Anybody who can explain me this?
One to many.
One to many
One to
from?
many.
One to many from?
R to A.
From A to B. It is one to many from A to B. Correct, na? Yes.
Yes.
It is one to many from A to B. So how to interpret this? Entity from entity set B is associated with at the most one entity from entity set A, whereas entity in entity set A is associated with any number of entities from entity set B. Towards A it is 1 and towards B it is many. So how to interpret this? Entity from entity set B is associated with at the most one entity from entity set A, whereas entity from entity set A is associated with many number of entities, possibly 0, from entity set B via this relationship set R. Am I correct? Yes.
Yes, ma'am.
So have you understood this? We are supposed to make use of such constraints while drawing the ER diagrams. So please be clear with the concepts. Right? So we have seen 4 mapping cardinalities and how to denote those cardinalities and what is the interpretation of these mapping cardinalities. One to one, one to many to one, and many to many. Right? Now, I would like to cover one more concept and then we are going to conclude. So, participation of an entity set in the relationship set. So, we have seen these concepts actually earlier, right? Right now, we are using the same concepts with the ER diagram, how to depict it pictorially, right? So, we have seen that there is total participation and there is partial participation. So, what we mean by total participation? If every entity in the entity set participates in at least one relationship in the relationship set, then we say that it is total participation. Every entity must participate in the relationship set. If this is the case, then it is total participation. And what is partial participation? Some entities may not participate in any relationship. Some entities are not involved in any of the relationships in the relationship set. If this is the case, then we say that it is partial participation. If in ER diagram, if we would like to depict total participation, then we are making use of double line. So, how to denote it? Just see this example. What we have, once again, instructor and student. These are two entity sets. Those are participating in the relationship set advisor. But towards student, it is total participation. So what we mean by that? See here how we have denoted it, this total participation with double line. So what we mean by that total participation? This total participation means every student must have at least one instructor associated. Every student must have at least one instructor associated. So every student is participating in this relationship set advisor, and that is why it is denoted here as total participation. But participation of instructor in advisor is partial. What we mean by that? Participation of instructor in advisor is partial participation, meaning some of the instructors may not be associated with any of the students. Some of the instructors may not advise any of the students. So these instructors are not involved in this relationship set advisor. So this is partial participation. So total participation is denoted by making use of double line, and partial participation is denoted with the simple line. Right? So total participation means every entity in the entity set is participating in at least one relationship in this relationship set. Whereas what is partial participation? Few of the entities from the entity set may not participate in the relationship set. If this is the case, then it is partial participation. Have you understood the concept? Yes?
Yes, ma'am.
Any doubt?
No, ma'am.
Fine. So we are going to conclude this session. In the afternoon, in the laboratory session, we are actually going to draw ER diagram for a real world problem. So whichever concepts right now we have covered, based on that, we will try to draw the ER diagram for the given problem statement. Okay, fine. So let's conclude the session today. I'll be posting the link for the quiz. Right? And everybody should respond to the quiz. Okay, fine. So thank you and see you in the laboratory session.